Hi everybody, my name's Addie, and along with Jake, Clark, and Philip, we are Team No Spoon, and this is our final report.
Instead, only try to realize the truth.
What truth?
There is no spoon.
There is no spoon?
Before we get into the rest of the presentation, here's a brief recap on the project problem understanding. During the competition, each team must complete several tasks as seen in the movie The Matrix. The first task is to defeat the Sentinel by removing it from the team's home zone. Next is to gather the programming modules by bringing them into the home zone. Then the pills must be deposited into the Matrix, into the red zone and not the blue zone. Finally, the team must retrieve Morpheus from the Matrix. On the screen, you see the point allocations across the various tasks that the team must complete, and there are varying levels of completion for each task as well. There are several requirements that the machine must meet in order to compete in the competition. The final machine must have dimensions no larger than 24 by 18 by 12 inches, and the total cost of the machine, excluding fasteners and paints, must not exceed $100. The machine must be set up and boxed within 2 minutes and 45 seconds and complete all competition tasks within 40 seconds. Additionally, the machine must not activate until it is triggered by the banana plugs. Failure to meet any of the requirements results in immediate disqualification. The most important engineering requirements were those that allowed the team to compete in the first place. Requirements coming from the competition guidelines include the easy setup time to fit within the limited time period, keeping within dimensions, and running autonomously. Critical requirements that were determined by the team include structural strength and simplicity. Important customer requirements include repeatability and consistency of the machine to maximize points. On the screen, you see the function tree, which has been presented in the past few presentations. The main function is to complete all competition tasks, which were defeating the Sentinel, gathering programming modules, placing the pills in the red zone, and retrieving Morpheus. All these tasks can be completed in various ways as seen in the sub-functions. The Gantt chart displays the timeline of the entire design project in a way that is easy to decipher. This chart ensures that all reports and sub-functions were completed by their due date and made sure the team had ample time to repair and change the design as needed.
For our final competition strategy, we decided to focus on 3 subsystems and ignore the Morpheus subsystem. We deemed the risk greater than the reward, as we might disqualify from the final competition. The spatula design features a scissor arm that extends to the center of the playing field to deposit pills and retrieve Morpheus after the shield is dropped. The Sentinel will be pushed by a hinged arm into the EMP zone with wheels attached to the end. The programming modules will be collected using 2 arms with mousetraps attached that will flip out past the programming modules and be retracted with a DC motor pulling the modules into our home zone. The Whisk design scores points in a similar fashion to the previous design. However, it uses a swinging arm to knock the Sentinel into an adjacent zone, lowering an opponent's team's score. The Spork design features a platform attached to drawer slides that extend to the center of the field. A switch attached to the base of the platform detects the zones in the matrix and deposits ping pong balls into the red zone by activating a solenoid. An IR sensor will be used to detect when the shield around Morpheus drops, triggering a mousetrap to deploy an arm to trap Morpheus in the net. The programming module subsystem features 2 sweeping arms on either side of the machine that will flip out onto the field using mousetraps and swing towards Zion, scooping the balls into our home zone. The Sentinel will be once again pushed into the EMP zone. The Ladle design features an approach similar to the previous design, but instead of has a Sentinel subsystem designed to take points away from the opposing teams. Once the drawer sides extend, a mousetrap triggers, swatting the Sentinel into a neighboring zone. In this design, the lower drawer slide system does not need to be retracted for the egress score to count. This modular approach to the design would allow us to work on each task independently, but may cause issues with space constraints. The Fork design features 2 separate pill depositing systems attached to the platform, allowing us to place pills in both red zones and double the pill score. The Sentinel will be scooped up when the drawer sides are retracted by a DC motor and brought into Zion to prevent losing points. Adding a support wall on the outside of each drawer slide gives the machine added stability when extended and improves the overall aesthetic of the machine, giving it a cleaner look.
The Fork was chosen as the final design due to its high scores in stability, target accuracy, and simplicity. The drawer slides and unfolding arms were very consistent when it comes to reaching the matrix and the tennis balls respectively. The simplicity of this design lies in the compact nature of all the moving parts. The design that used the scissor arm suffered from a severe lack of stability, which would lead to poor target accuracy. The scooping arms ended up being difficult to work into the machine due to it being difficult to try and find a way to make the design compact while not interfering with the other subsystems. Designs with the Morpheus arm took a hit in consistent task completion due to the difficult nature of obtaining Morpheus and not disqualifying. In the first preliminary competition with the program module arms, we averaged 2.67 balls per run, and the unfolding arm design proved to be something that was very consistent and actually made it all the way through to our final design due to its consistency and compact nature. The arms were made thinner though, and the mousetraps were repositioned. The method of using string to operate almost everything stuck because despite the pain of untangling string, it was still fairly consistent. In the second preliminary competition with the Pill and Morpheus subsystems, a small coding error caused the machine to fire too early, which led to a disqualification. The error was fixed right after the competition, but it was too late. This proved to be an important lesson that any change to the code can have a large effect no matter how slight. In the qualifying competition, the code was checked again and again to prevent another disqualification. The first attempt at a sentinel arm was very inconsistent and never once removed the sentinel from our zone. This led to a complete overhaul of how that particular subsystem worked in our final design. The program module arms were also very inconsistent, due in part to the method used to launch them never working. We were using wedges attached to the drawer slides, which never once knocked the arms over. They were only knocked over when the motor pulled the string underneath them and pushed them over. This was a complete accident, but ended up being the method we used to launch the arms in the final design, and it was very consistent.
Our final design that we brought to the competition was very similar to the fork mentioned before. The main differences are the elimination of the two short wings from the programming module arms as they hit the drawer slides on their way out, causing them to release too slowly, and a support wall in place of the cross supports for purely decorative purposes. Our Pill subsystem consisted of a platform attached to the drawer slides that was slid out using a pneumatic actuator attached to the machine. The system slid out to the matrix, and two PVC pipes with solenoids attached were used to launch the pills at the correct time. A switch on the front was used to determine when the red and blue zones were in front and allowed us to launch the pills into the red zone and not the blue. Underneath the platform was a hinged arm that was supposed to be used to collect the sentinel. It did not perform very well in the final competition, but it was also used as part of the egress where the string was attached, so it functioned in that way. The programming module was, as mentioned before, a hinged arm with a mousetrap at the hinge that launched using a pneumatic actuator that pulled string from below. These are actually adjusted for the final competition by sawing the mousetrap in half and using the hinge, or putting the spring closer to the hinge, causing them to fly off faster. The final cost of the machine was $61, mostly due to the drawer slides, which was very much under the $100 limit and very good considering how we placed in the final competition. Now on to the final competition. We were seated 54th due to the aforementioned issues during the qualifying round, and here to the right is our poster and our setup for the design review. In the first round, we had some difficulties with the hook screw and the latch not working quite right, and we were not able to box in time, leading to our disqualification. But in the second round, seen in this video, we did very well, coming in second place, scoring 68 points. Our pills functioned almost perfectly, with the problem of having the two balls come out a little too quickly for the second zone and hitting each other, causing one ball to fall out. But we got 3 programming modules and did fairly well. Arguably our best round was the third round, which we ended up winning. We got the pills in the same way as we did in the second round, but our programming module arms were not quite fast enough to beat the other teams, leading to us receiving no points for that. In the fourth round, we ran into similar issues that we did in the first round with the hinge and latch not working, and almost disqualified, save for Jake at the end hinging or pinning the platform down, preventing us from scoring any points from the pills or sentinel, but allowing us to get the programming modules, leading us getting 1 point in the final round. In the end, we made it 4 rounds. Our unfortunate incident in round 4 caused us to lose out then, but we came in 21st overall based on wins round completed. As for future improvements, we could have added a Morpheus subsystem. We deemed it too risky at the time, but watching other teams go, it seemed as if it did fairly well. We need a better activation device for the drawer slides, and using actuators on programming module arms would cause them to come out faster. As for lessons learned, we learned a lot about machining and mechatronics, and we had a lot of fun. Any questions?